Biomolecules. Biomolecules means what? They are the certain compounds which are very important to the body. Okay, for example, you can say carbohydrates, or proteins, then nucleic acid, lipids, and so on. Okay, so whatever chemical changes which we study in the living system is called as biochemistry, and that mainly deals with what? The study of the biomolecules, because all the components if we see on earth, it's made up of what? Carbohydrates, proteins, or nucleic acids, or lipids. Okay, so these are very important components. Now under this we are going to study all the categories one by one. So the first one that we are going to learn is about the carbohydrates. Now, what are carbohydrates? Okay, carbohydrates are nothing but they are optically active polyhydroxy aldehydes or ketones. Okay, so these components, what they do is they produce some certain units when they are hydrolyzed. So polyhydroxy aldehydes or ketones. That means aldehydes functional formula is CHO, and aldehydes ketones is C double bond O. Okay, so the general this one definition of carbohydrates is nothing but simply they are the hydrates of carbon. Okay, then they are having certain general formula, means any carbohydrate if you take, they are having a general formula which is CnH2O. Like for example, you can take glucose. Okay, that is C6H12O6. So this is the general example of a carbohydrate. There are n number of carbohydrates which are present. Okay, which we'll learn further, obviously. So whatever carbohydrates are there, generally the examples which we take is either glucose or either we take the fructose as an example. Other than that, lactose, sucrose, many things are there. Okay, but the common type of body sugar, if you say, is nothing but the glucose. Glucose is what? It's a body sugar. Okay, so these carbohydrates, they are being classified majorly into three types. So three types, okay, that is first one is called as the monosaccharide. Second is the oligosaccharide. And third is the polysaccharide. Okay, now mono means 1. Okay, oligo means 8 to 10. And poly means n number. And saccharide meaning sugar. Okay, so monosaccharide means only one type of sugar will be present. Oligosaccharide means 8 to 10 units of the sugar may be present. And polysaccharide means what? N number of sugars may be present. So monosaccharides are certain because only they are having one type of sugar. So you cannot hydrolyze them further so that they can give any aldehyde product or a ketone product. Okay, so generally 20 different monosaccharides are present. I'll just write it down. Monosaccharides. Okay, so monosaccharides are what? These are the compounds, or these are the carbohydrates that cannot be hydrolyzed further to give simple units. And there are about 20 monosaccharides. Okay, then the second one, as I told you, oligosaccharide. So oligosaccharide 8 to 10, and minimum, like you can take it as 2 to 10 also. Okay, 2 to 10 units they have. So because they are having 2 to 10 units, they can undergo what? Hydrolysis. That is breakdown into the simpler components. Now this particular oligosaccharide is further divided into 3 types, mostly the 3 types. That is disaccharide, trisaccharide, tetrasaccharide. So again the same, okay, di means 2, tri means 3, and tetra means 4. Okay, so depending upon how many sugar units are present in that chain, we name it as what? Di, tri, tetra, okay, and so on. So most common type of oligosaccharide, if we ask, is the disaccharide. Okay, this is the most common type of oligosaccharide. Common type. Okay, then coming towards the third one, which is nothing but the polysaccharide. So poly means many, as I told you. So in this polysaccharide also, because they are having large number of monosaccharides, means units of monosaccharides. So obviously they will also undergo what? Hydrolysis. So they are going to yield large number of monosaccharide units on hydrolysis. Like for example, you can take starch. Now starch is made up of n number of glucose units. So if you break down the starch also, it will give you what? Many units of the glucose itself. So even the same way, another example is you can take cellulose. Okay, cellulose is also one example of a polysaccharide. Now here actually the polysaccharides which are there, they are not sweet in taste. Okay, so sometimes they're also called as what? Non-sugar. So there are basically 2 types of sugar and non-sugar. So this is a simple term. Okay, those which are sweet in taste are called as sugars, and those which are not sweet in taste, they are called as what? Non-sugars. Like that, one more important term is there in this, which is called as reducing agent and non-reducing agent, or sugars you can say in this terms. Reducing sugars and non-reducing. What is reducing and non-reducing? In the term itself, the meaning is there. Reducing means it will reduce. Non-reducing means it will not reduce. So reducing sugar means what? Okay, these are the carbohydrates which reduces Fehling solution and Tollens reagent. Okay, so these kind of sugar, what they have the capacity to reduce these two types of solutions or a reagent, which is called as what? The Fehling solution and the Tollens reagent. Okay, so actually what happens here is whatever the functional group is there, either it is the aldehydic group or the ketonic group, that has been reduced over here. So all the monosaccharides, which is having aldose as well as ketose, you can take the examples over here. Okay, so I'll just write it down. That is, here what happened is reducing functional groups. So those functional groups are nothing but the CHO and C double bond O. Okay, that is the aldehyde as well as the ketonic groups. So example you can take over here is the all monosaccharides and disaccharide with free reducing groups. An example of disaccharide over here is maltose and lactose. Then what will be non-reducing? The opposite. Okay, so these kind of sugars or carbohydrates, they will not reduce the Fehling solution or the Tollens reagent. Like for example, a disaccharide sucrose. Example, sucrose. Okay, so here the main important thing is the monosaccharide, because monosaccharide, it contains what? Now, if as I told you, two types of functional group is there. One is called as the aldehyde as well as one is called as the ketone. So in a monosaccharide, it may either have an aldehyde group or a keto group. Okay, so if it's having aldehyde group, then it is called as aldose. And if it's having a ketonic group, then it is called as ketose. Okay, so depending upon whether it's an aldehyde or whether it's a ketone, means whether it's an aldose or a ketose, say suppose if we have carbon like 3, 4, 5, 6, and 7, suppose. Okay, like I'm taking this triose, tetrose, pentose, hexose, and heptose. So if these are the carbon atoms, number of carbon atoms present in each, then how you will pronounce, or what is the term which is used over here? Here 3 carbons are there. So you will say this as, if there is an aldehyde group, you will say it as aldotriose. Then if it's a ketone group it's having, you will say it as ketotriose. Okay, so this is how you name it. Now this is 4 carbon atom. So 4 means tetrose. So tetrose means, again, in front of the tetrose you have to add aldo. So aldo tetrose. Keto tetrose. In the same way, you have to name the pentose, hexose, heptose, and so on. Okay, so this is how the naming of the monosaccharides are being done. So as I told you, glucose is one of the main common sugar which we take into consideration, and it's almost freely occurring sugar. And sometimes you will also find it in what? A combined form. So if you take fruits, if you take honey or any other ripe products, so mostly it will be containing what is the glucose. Okay, so there are certain methods and there is a certain type of structure that we are going to learn now about the glucose. So let's see it. So glucose. Now, whenever we are going to prepare a glucose, okay, there are two methods which are mostly used in the preparation of the glucose. So first one is from sucrose. Okay, so how we are going to prepare the this one glucose from the sucrose is, now sucrose is nothing but the cane sugar. Okay, so in this process, what is done is the cane sugar or the sucrose, it has been boiled with a dilute HCl, that is hydrochloric acid, or H2SO4, that is sulfuric acid, in alcoholic solution. Once you do that, you're going to get two types of products over here. So I'll just write it down. Okay, so what you're going to do is the sucrose, you're going to boil it with dilute HCl or H2SO4 in alcoholic solution. So the reaction is, the formula of sucrose is C12H22O11 plus water will give you C6H12O6 plus C6H12O6. One is the glucose, another one is the fructose. There's just a slight difference between the the 3D structure of the glucose and the fructose. Okay, rest other than that, the formula is same. So this is sucrose. So this is the reaction for what? How will you prepare the glucose from the sucrose? The second method how you can prepare is by using starch. Now, as you know that starch is made up of n number of glucose units. Okay, so mostly the starch is used for producing the glucose commercially, that is industrial point of view. So here what is done is the starch has been hydrolyzed. Hydrolysis of starch by boiling it in dilute H2SO4 at 393 Kelvin pressure. Okay, so it is like C6H10O5 N plus NH2O will give you NC6H12O6. This is glucose. This is starch. Now here, starch is also made up of n number of glucose unit. Cellulose is also made up of n number of glucose unit. So the formula remains same for the starch as well as for the cellulose. Okay. So these are the two methods by which you can prepare glucose, that is from sucrose as well as the starch. Now, as I told you, glucose, even though if it's a monosaccharide, it is also called as what? An aldohexose. Okay, so if you see the structure of the glucose, okay, glucose is an aldohexose. Aldo means aldose, okay, and hexose means 6 carbons. Fine, because its molecular formula is what? C6H12O6. Okay, so there are some things, okay, which you have to consider over here. Like there are some important reactions, okay, which is very important, which depicts the structure of the glucose. So first of all, the first reaction, okay, that we are going to say is the basic, this one I'll write over here, CHOH 4 times CH2OH. Okay. Okay, glucose. Now here, if we heat this glucose, okay, for a long period of time with HI, then it is going to form a product which is called as N-hexane. Okay, means if I'll heat the CHO with HI, then I'm going to get what? N-hexane. Okay, in the second reaction, whatever glucose is there, it is going to react with hydroxylamine so that it can give oxime and cyanohydrine. Okay, now how we'll get a cyanohydrine is, it is going to add a hydrogen cyanide over here. Okay, these reactions just you have to study it. Okay, because in MCQs also they will ask what forms what. Okay, so the reactions is very important over here. So as I told you, the glucose, it reacts with the hydroxylamine. So they will give one product, that is the oxime. And again, what happens is the hydrogen cyanide is being added to it, and then it forms a product which is called as the cyanohydrine. Okay, so this confirms that there is a presence of what? C double bond O group. Okay, then next reaction is what? The glucose, when you oxidize it, to the carboxylic acid, by reaction with bromine water. Okay, if you carry out this reaction, then it will indicate the carbonyl group is present in an aldehyde. Okay, carboxylic acid means over here gluconic acid. Gluconic acid. Next is acetylation. Okay, what happens if you do the acetylation reaction of the glucose? Okay, so if there is an acetylation of glucose, so if it's an acetylation, so you have to use an acetic compound. Okay, so that is acetic anhydride. Then it will give you glucose pentacetate. So this reaction, what it confirms, see, every reaction is confirming something. So this reaction is going to confirm the presence of 5 OH groups. Okay, and the last reaction is when there is an oxidation with nitric acid, whatever glucose and gluconic acid is there, they will give dicarboxylic acid. Which means it indicates the presence of primary alcoholic group in glucose. So these are the reactions which shows the presence of, or which indicates the presence of certain groups in a glucose molecule. So now any type of molecule, if you take, like for example, glucose or the fructose, they're having different, like 2 types of forms, okay, D form and L form. So there are certain terms, okay, that you should keep in mind while you're learning the compound, that is glucose, as well as what? Fructose. And even structural arrangement, if you see the structure. Okay, there is a Fisher and Haworth structure. So two types of structures are also present for the glucose as well as for the fructose. Okay, so as we are going to see the glucose now, so let's see what is the structure of the glucose in a by the Fisher arrangement. So this is what the structure of glucose. Okay, so mostly, as I told you, there are two types of stereoisomers. If you see over here, one is the D and L according to the optical activity which they produce. Now, optical isomerism, which is there, that is in a plane polarized light. Okay, whenever you see two things, like for example, if you take enantiomers, okay, enantiomers means what? They are the mirror images of each other. So, like if you see yourself on a mirror, you will see that your left and right, they are like opposite. You will find out in the mirror. The same way is here also. Okay, enantiomers or the L and the D which is there, it is opposite forms. Like for example, if I take the D or if I take the L glucose, now what is the difference over here is, if it's a D form, okay, then whatever OH group is there on the asymmetric carbon atom from the farthest aldehyde or ketone group, on the right it will be. Okay, so OH group, it will be where? On the right if it is a D form, and if it's on the L form, it will be left. Okay, now what is this asymmetric carbon atom? Okay, asymmetric carbon atom means the carbon atom attached to 4 different types of atoms or group of atoms. Okay, so if there is a C, it will be attached to what? 4 different types of atoms. For example, if I take here CHOHCHO, 4 different types it is, right? So that is called as what? Asymmetric carbon atom. Okay, so on the asymmetric carbon atom is, if whatever the OH is there, if it's on the right hand side, then you say it is a D glucose. In the same glucose structure, if the OH which is attached to the asymmetric carbon atom is on the left hand side, you see it as what? L glucose. Okay, that is dextro glucose, dextro and levo. Even depending upon the plane of rotation, like how there is a rotation, right? If it's a left side rotation or the right side rotation. Suppose if it's a right side rotation, you say it as dextro rotation. And if it's a left side rotation, you say it as levo rotation. Okay, so like that. So that is the configuration which has been given on both the things. Okay, whether if you take the structure of the glucose also same only, and for the fructose also same meaning only of the D and the L forms. Okay, so if you see the cyclic structure of glucose, okay, so in the cyclic structure of glucose, actually it will be like a Haworth like this one projection, cyclic structure. So say suppose if it is a open chain, okay, open chain structure, so it will not explain certain things that I'm going to write over here. For example, consider an open chain structure. Okay, open chain means this type of structure which is there. Okay, so it will not, what do you say? Like are the reactions which I told you, right? The above reactions, which indicate some kind of groups which are present in the glucose. So suppose if it's an open chain, what will happen is, despite if suppose if it's having a aldehyde group, so glucose, it's just a points, okay? Suppose if it's having an aldehyde group, okay, the glucose will not give 2,4-DNP test, or you can say sniffs test. Okay, so certain reactions are there in this, because what happens is the glucose which is there, it exists in two form basically. Okay, one is the alpha and other one is the beta form. So this two forms is what called as crystalline forms of glucose. So crystallized form of glucose means what? Whenever you are heating it, like for example, if it's an alpha form, so you obtain that alpha form of the glucose by crystallizing the concentrated glucose under a certain temperature. Okay, in the same way, beta glucose also see. Just what happens is the temperature which is there, that is different in both of the things. Okay, so if it's an open chain structure, it is difficult to show those things. Okay, and one more important thing over here is what? The anomer as well as epimers. Okay, so glucose, actually they are having what? Anomers and the epimer structures. So what are these anomers and epimers? Anomers means nothing but they are the pair of optical isomers which differ in configuration only around carbon 1 atom. Okay, so whatever the configuration is there, that will be different around the carbon 1 atom. That is the first carbon atom. For example, alpha D glucopyranose and beta D glucopyranose. Then epimers. Epimers means they will differ around any carbon atom other than the carbon 1. The carbon 1. For example, D-glucose and D-mannose.